Hello and welcome everybody to today's Association for Manufacturing Excellence webinar series titled The 5 Principles of Lean, a 4-part introduction to lean thinking. Today's fourth and final webinar in the series is titled Head Towards Perfection. I'm Dave Desker, Vice President of Marketing at AME Canada, and I'll be your moderator. Today's presenter is Richard Evans, the President of JR Lean VP Programs East for AME Canada, Chair of Lean Certification Oversight and Appeals Committee and Training Within Industry, Certified JI and JR Instructor. Richard has spent the past 4 decades helping companies become more effective in delivering quality and value to the production process while focusing on customer success. Having a manufacturing engineering background, Richard helps organizations to recognize waste through mentoring, coaching, and applying lean principles, tools, and techniques. His extended knowledge of various industries include automotive, aerospace, railroad, packaging, food processing, printing, and fasteners have enabled him to quickly focus in on opportunities for improvement. During the last 10 years, he assisted companies in developing lean transformations and has facilitated over 50 Kaizen events. Before we start, just a couple of housekeeping items. You'll be in listen-only mode throughout the webinar. You'll see that you're muted on your attendee panel on the right of your screen. If you have questions during the webinar, please type them into the question area in the attendee panel and click on Submit. We'll review the questions at the end of today's presentation and answer as many as we can. When you log off today, please check your email inbox. In it will be an invitation and a link to fill out a short webinar attendee survey. Please take a few minutes to complete the survey today, as your feedback is very important to us to improve future webinars. Richard has also graciously agreed to provide a PDF of today's presentation. We'll be sending that along with a recorded link for a webinar replay to each of you next week. Now I'm pleased to introduce Richard Evans, who will present Head Towards Perfection. Take it away, Richard.
Dave, thank you very much. Thank you. Good morning, everyone. Good afternoon, and a Happy New Year. Happy 2017 to everyone. Unfortunately, I've got a little bit of a head cold today, so please forgive me if my normal funny accent isn't the same. But we'll manage to get through the presentation, I'm sure. The session today is part 4, which is Head Towards Perfection. If you recall, the 5 principles of lean, as described in Jim Womack's book, Lean Thinking, starts out with value for the customer. The next principle then is to identify your value stream. So you need to understand how your value for your customer flows through your organization. The third principle is make the process flow. So we look at the wastes and we attempt to remove any wastes and improve that flow of value through the organization. The fourth principle, you remember, is let the customer pull. So now you can tune your production in line with customer demand, and the customer is now pulling your work through your organization. The final principle is head towards perfection, and we're going to talk a little bit about that today in this part 4 of our 4-part series. Head towards perfection. So the definition of perfection is the complete elimination of waste. And as you probably realize, if you perform tasks within your organization, there is inherently a lot of waste that exists as you move from one process to another. And in order to have the complete elimination of waste, one of the things that you must fundamentally do is to standardize the way that you do things. So if you're now currently performing tasks and there are multiple people performing those tasks, and if those multiple people are not doing it exactly the same way, then you've got variation. And if you've got variation, you've got waste. You've got things that are occurring that are increasing either your lead time or the cost of the job, or the quality, reducing the quality of the part. And as we learned previously in our other 3 sessions, our value for the customer is measured through QCD, quality, cost, and delivery. So today's webinar is going to be on standardized work. However, before we do that, I'd like to go back to last month's webinar, if I could, just very, very briefly, and bring up the poll question that we had near the end. And one of the themes of the previous session was Kanban, or pull system. And the question that I asked was, a production Kanban is A, either a traditional work order, and 2, a card that is sent to production control, 3, a signal to production to start working, and 4, a signal to an upstream operation that more work is required. The correct answer is number 3, a signal to production to start working. And the majority of you actually identified number 4 as the right answer. And in many cases it would be the correct answer, but there are occasions where it's not. For instance, if you are manufacturing an assembly, and this assembly takes a number of steps in order to get to its final version, there could be an occasion where you might be 3 steps from the end, and you need to trigger another sub-assembly to be made so that it meets the final assembly at the very last process. It comes together. It could be a housing, it could be special crating that's needed, and because there's a lead time involved in making that special sub-assembly, you want to signal it at a certain point. So now this would be a Kanban, a production Kanban, that is not sent upstream, but is actually sent to another value stream offshoot in order to start production. So I just wanted to clarify that poll question, because unfortunately we ran out of time in the last session, and I wanted to make it clear why the production Kanban is a signal to production to start working and not necessarily to an upstream operation. It's not merely replenishment, but it could be a trigger to make a product. So with that one clear, let's move on. So what is standardized work? So we really want to make sure that we capture the knowledge that exists within our organization. And there are many, many ways of doing work. We know that. But what we've got to do is to try and understand the best way to do the work and to capture that best way. So we can define it as the rules that tell everyone the best way we know today to do a job. That could be one way of describing standardized work. It's also a defined method to perform a task or several tasks in order to produce or deliver the best quality part or service in a safe manner within a predetermined time frame. So this is what standardized work is. It's the rules that tell everyone the best way we know today to do a job. So why is it important that we capture this knowledge? Well, the first thing that you want to understand is that if you don't have a stable process, if you don't have stability, then you can't improve. You've not got the right conditions for continuous improvement if your process is unstable. And if people are doing a job differently, then you've got instability. So in order to make sure that we can improve and get better and better and better, we need to stabilize. In order to stabilize, we need to standardize on the way that we do the job. And that way, once we've stabilized and standardized, we can then improve, which is the goal of every organization. So what really is standardized work? Some of you may have seen this before. Some of you, it may be new. I'm going to show you a video. Hopefully it'll come through. And I'm going to loop it a few times just to make sure that we get it right. Okay, so let's just have a look at what we've got here. It's in Japanese, so you probably can't hear the sound very well. So we're going to play that again. So this is the sequence of folding a t-shirt. I've used this many, many times in introducing organizations to standardized work. And the purpose, obviously, is to be able to provide anyone with instructions on how to do this particular task, as well as showing them the video so that they could perform the task. I'll show you one more time. A number of people ask me, what is the purpose of standardized work, the written standardized work? And a lot of people understand or think that it's so that the people can actually follow the instructions and when they do their job. But if you think very literally about people performing their tasks on a regular basis, are they actually looking at what the instructions tell them, or are they doing most of their work from memory? And the correct answer is that they're doing most of their work from memory, certainly repetitive tasks. So what's the purpose of creating standardized work? Well, you've got obviously a reference that is the methodology, the way how to do a job. Let's say that your team, who are performing some very complicated tasks, win a major lottery, and they all leave on the following Friday, but you've still got to get production out because they didn't let you join their lottery team. Now, you can use the standardized work to actually go do the job. And I've known many organizations that use that standardized work in order to create the production quota. Certainly when they might be in employee issues where they might be striking or something like that. So it's a record of how to do the job. The second purpose of it is to be able to audit or check that the people are actually doing the work they're supposed to be doing in the certain way they're supposed to be doing it. So you've got a record that shows you how to perform the task, and then you've got it as an audit to make sure that the people are actually performing that task as well. So let's go through how to create some standardized work, and we'll use this particular t-shirt folding as an example. In this particular case, we're using a job breakdown type sheet, and we're going to do the process of t-shirt folding. And what we're going to do is to create some standard work. This is not actually a job instruction breakdown, but this is standard work that you're going to see now. So what we're going to do, we're going to say our first step is to lay flat. And we're going to have the front up, the neck to the right, and the sleeves flat. So we've started off showing somebody exactly how to do this particular job. The second step, is what we call a left-hand pinch. And we have an imaginary line in the middle of the shirt, the second line from the sleeve, and then we're going to pinch both layers of the shirt with the left hand. And we're now starting to position the fold. The third step is the right hand pinch. An imaginary line from the left hand back to the sleeve, and then pinch both layers of the shirt with the right hand. The fourth step is right hand over to hem. And we're bringing the second pinch in front of the left hand and down to the hem. The fifth step is to pinch the hem with the right hand. Pinch both layers and in a line with the first, and then second pinch. The sixth step is what we call a flick, where we uncross our arms and at the end of the movement keep the hands horizontal. We're giving some reasons for each of these points as well. And then the seventh is what we call the flop and fold. Lower sleeve first, and then fold towards you. And we're providing some images of the work as well. Now, I've just done this one just to show how you could create some standardized work very simply using a video of the actual task being performed, as well as some step-by-step instructions that are complemented with clips from the video as well. So you've got then a full breakdown. We've also got some images where we show the sequences, the steps, in order to get where we have to go. And the final result is obviously in the middle. So we've given some work instructions, we've given some visual work instructions as well, in order to create some standardized work. Another way you could do it is by having a training aid instead of the images that essentially give you more information as well pictorially. So in this case, we're showing where the person stands in step 1, and then in step 2, where they're going to pinch. In step 3, where the right hand pinch is. In steps 4 and 5, where they're folding over. And then step 6, where you do the flick, the uncrossing of the arms, and then when you do number 7, when you're actually getting the arm under and you fold it over. So there's a number of ways that you can convey standardized work. We have to obviously develop the thinking. And in order to have stakeholder success as well as customer success, there are 3 elements in your organization that are involved. There's the people, there's the process, and then there's technology. And you start off always with the people. So you must have sustainable thinking and employee involvement. And in order to create standardized work, you need to go to the people who do the job every single day. You need to get them to agree the best way to do the job. Why? Because they're the most experienced. They also understand the time aspect the best. They also understand the quality aspect the best. So create your standard work through your people. Then apply it to your process, because then you can make your process flow through continuous improvement and elimination of waste. And once you have stability in your process, you can then apply technology, tools that will support the people and the process. But you've got to start with standardized work, with the people. So develop your thinking first. This might be true in your organization, the top image, that you've got inconsistent processes, but you've got some very, very, very good people doing whatever they can to get results. But if you've got an inconsistent process, the output is going to be inconsistent as well. And you're going to get inconsistent results all the while. If you standardize and stabilize your process, and you get people working to those standard processes, then you're going to get consistent output, and you're going to get desired results. So traditional is people doing whatever they can to get results, and there is a lot of firefighting that's going on most days. And then we talk about lean, and that's people using standard processes to get good results consistently. So a quality process equals a quality result. Once we've established a standard, if we make any change whatsoever, then we have to re-establish that standard. If you don't re-establish that standard, then you will slip back. So therefore, the wedge that puts in the prevention of slipping back is what we call standardization. So it's quite important that if you do make a change within your process and that change has been approved, then you have to standardize it. So create the standard and make sure that everyone follows that standard, and you'll get continuous improvement, which obviously takes you to world class. So if we look at our focus on capturing knowledge, we have a number of elements that come into play in organizations all the while. We've got cost, we've got safety, we've got flow, we've got quality. I ask quite a number of organizations, what is the order of importance of those elements within your organization. And it's very interesting that the people who add the value, they give them to me in the correct sequence. Obviously, safety number one, because your people are your biggest asset within your organization. But then number two is quality, because that's what your customer demands. And that's the only way you get paid, is providing a good quality product to your customer. The third one is flow. If you've got a quality standard product working through standardized work, then you make that flow and your cost is going to be managed. So it's interesting that I mentioned the value adders, give them me in the right order. But then I asked the value adders the next question. What do management focus on all the while? And the answer comes back immediately: cost, cost, cost. And what does that tell you? It tells you the leadership are not quite engaged in how lean works. They're not engaged in what to focus on. You are not going to save cost by focusing on cost. You're going to save cost by focusing on the elimination of waste. So understand that, of those four elements: safety, quality, flow, cost. That's the right sequence. So let's have a look at some definitions of terms when it comes to standardization. So standard work, the best current method of safely combining process inputs in order to achieve quality, cost, and delivery every time. The best current method of safely combining process inputs in order to achieve quality, cost, and delivery every time. That's standard work. Standardization is the process of eliminating variation leading to standard work. Standard operations, these are the documents that capture the standard work. So we have things like standard work combination table, a work chart, and job detail sheets, visual work instructions, etc., etc., etc. And we're going to show you some of the documents as we move forward. Cycle time. What's the definition of cycle time? The time it takes for one complete cycle of work to be performed. The time it takes for one complete cycle of work to be performed. Then we have a definition of takt time. And we've talked about takt time in session 1. And this is the German word for rhythm or beat. So it's the rate at which you need to produce products in order to satisfy customer demand. So if you have 500 parts per week and you're working 5 days a week, then you can say that on average you need to produce 100 parts per day. Now, depending whether you work 16 hours a day, or 8 hours a day, or 24 hours a day, then your takt time will be different. So it all depends on your available production time. And what you do is you take that available production time and divide it by your customer demand, which gives you your takt time. So if you're working 24 hours a day, then you take away any breaks and you divide that by your customer demand to give you a takt time. What is takt time used for? Essentially to make sure that your line is capable of meeting customer demand, because that essentially at the end of the day is what's vitally important. So use takt time as a really good measure for your line, as opposed to cycle time. Cycle time you can use to determine whether or not your resources need to be doubled or improved, but certainly measure everything through takt time. Because if you can perform to takt, then you're working to customer demand, which is fine. The standard work is in all parts of the business as well, not only in production, but it's also in information flow. And it also applies to leaders. And we're going to share some of that with you today as well. So let's have a look at standard work in production flow. This is what we call a standard work audit sheet. Okay, if you're in Canada, you'll recognize that Tim Horton is actually the person preparing the coffee. And if you look at the steps that we've identified, we've got 7 steps in order to make a cup of coffee, and then you go back and sit down afterwards. There is some processing time in there, and in this particular case, we've got some 41 seconds of total time, and then we've got about 7 seconds of walking time. So our total cycle time for this particular task is 48 seconds. And we've identified on this standard work audit sheet the elements that it takes you to go and make a cup of coffee. And then we've obviously got a quality check just to make sure that everything is right, and we haven't used safety on this one or standard WIP elements as well. So that's just an example of using a standard work audit sheet. This is another type of standard work in production. It's what we call a job breakdown sheet. In this particular case, this is used in more or less in training somebody in doing a job, and I'm going to get into this a little bit further into the session that shows you how to train a person to do a task. But this was the sheet that we used in order to create some standard work for the folding of the t-shirt a little bit earlier. Standard work in information flow. We've got some elements in here as well that we want to be cognizant of. The first, when a task is to be performed. So you might have closing the books at the end of the month. In accounting, there are certain tasks that need to be performed in sequence. So you might want to identify those tasks in the sequence that they're to be performed. And also provide a guideline on how long the task should take as well. And obviously in the correct sequence. And then again in information, inventory. Inventory is information in administrative areas. So we need to know what information is available and where to find it. So this could be a close of month process. And there's obviously 6 days of activity in this particular one. And whoever's performing this, they've probably got this file in Dropbox or on the network somewhere within their organization, and they keep it up to date. So they understand what state or they're in, what stage they're at, and people checking can go and make sure that everything is done according to the schedule. So this is a very good example of standard work in information flow. So it's not just applicable to production. We also have what we call standard work for leaders. And the elements of that is really down to what tasks a leader needs to perform on a regular basis. So essentially, we look at frontline leaders initially being the first type of leader standard work that we would identify. And they might start off in the morning. The very first thing they do is check the call-in number to see who's not coming in today. The second thing they might do is understand the day's production before their start of shift meeting at, say, 7 a.m. And then they would perform the start of shift meeting and assign people the work and their tasks. And then they might go through a whole series of other things that they need to perform on a daily basis. And then maybe once a week they would have to do something, and then once a month as well have to do something. So they need to record that. They also want to track observations and action items when it comes to making sure that they're following up on any issues, any improvements, any problems that might need to be solved. So let's have a look. This actually is an operations manager, and you can see the time is on the left-hand side going down. That's his day, 7:30 till 5. And then he's got his whole week mapped out. How many of your operations managers have their week structured like that? Probably not too many. But this particular individual found that this helped him tremendously. And if we go through what he would do on a daily basis from 7:30 to 8, he'd review the daily schedule, review the startup, and check the previous day's numbers. And then he has a morning Gemba walk for 45 minutes with frontline management. And then 8:45 to 9, he's preparing for a meeting. And then at 9:15 to 9:30, he has a session called Morning Market, which essentially identifies the previous day's problems and what are we doing to solve them. Then a very short production meeting for half an hour. And then for 2 hours, he's actually doing some PDCA, plan, do, check, act. And he's doing problem solving. So he's actually going around, he's not looking at reports, he's not sitting behind his desk, he's actually working with the teams to make sure that they're working on the right things to solve the issues. And he gets his lunch, and as you can see, he's got an hour and a half for checking emails and other stuff, and then that's how his day goes. And on a Tuesday and a Thursday, for half an hour, he's doing continuous improvement on line 1 and line 2. So he's actually working with the frontline management or the people on the line and asking them and working with them to improve stuff. This surely is what leadership is all about, supporting the value adders. We mentioned frontline leaders, and here's an example of some frontline leaders at a it's a distribution plant for greenhouse growers. So they set up the line, and then they have a tailgate meeting, and they're organizing their staffing, and they're verifying something on their sign-in system, and then they support the line, and they start up the line after break. So you can see they're starting lines up after breaks all the while. And this really is their standard week, daily routine from 7:30 till 4:30. These are supervisors on different lines within this packaging company. Really good. Here's another one, another example that you could probably use. Again, you've got your daily things that you need to perform. In this particular case, they're not down to any standard time frame, but they do have to be done. And you've got notes at the bottom that help them to identify any issues that need to be followed up on. So daily, weekly, monthly, you could use something like this as well. And if you need any of these sheets, feel free to email me, and I'll send them off to you straight away. So let's have a look at some of the standard work tools that we've got and how to use them. These are the ones that we're going to go through, and I'm going to talk a little bit about each one as we go through. And we've got some poll questions coming up 3/4 of the way through, so we'll see how you follow the instructions that we're going to give you. The first one, safe job instruction. So this was an example of doing standard work using essentially a methodology that was developed many years ago, which I'm going to talk about a little bit later. So they've identified the steps and the sequence of the steps, and then they've identified under the key points the right things that you need to do for each particular step. And they've used symbols as well that tells them any safety requirements. And then, because we want to make sure that the people understand why it's important, we give the reasons for each of the key points that have been identified here. So this is an example of using a safe job instruction in place of what we call standard operating procedures. Standard operating procedures are usually created in order to satisfy ISO status requirements. And guess what? Nobody ever reads them other than the auditors or the people that have written them. so they're not worth the paper that they're written on. So this organization actually took all of their standard operating procedures and replaced them with this methodology. And the ISO auditor thought that this was phenomenal. And these became very, very much live on the floor. So there's a safe job instruction. You can see that it's all text. Okay, there's no pictures whatsoever. We then get to what we call visual work instructions. Now, visual work instructions are probably what we call the gold leaf of standardized work. And the visual work instructions are essentially to avoid any miscommunication, to make sure that we get the training steps correct, to make sure that we get the work steps correct. And we do not want to have any chance whatsoever of the people asking a question. If they have to ask a question, then we have not been clear visually in what we've done. And it's also used to increase the skill levels and obviously quickly positions employees into action faster so they get the job done. Here's an example of a very good visual work instruction, and essentially this provides you with a digital pictorial methodology of how to do a job. So you may have a situation where you're creating or you're assembling unique custom work. And if you're doing that, you've got to make sure that everyone is built correctly. You may have a lot of the content standard on these assemblies that you put together, but there may be some custom items that have to go on. This is when visual work instructions are solid gold. And you know the step-by-step methodology. You also can refer to any models or any drawings that will help you. And then if there are some health and safety or quality or environmental references that need to be cognizant of, then you can pull those up as well. So these types of work instructions are interactive. They're hyperlinked to other sources of information so that you don't have to go searching. And on a production line, these are tremendous. A time observation sheet is another tool that we use. And we use this to observe the operation and determine all the elements that make up that operation. We also use it to determine the lowest repeatable time per element. And we also use it to determine the lowest repeatable time per operation. So here we have a time observation sheet, and again we're using the making the coffee. So we complete our header first. We determine our tasks next, and then we time the operations without stopping. We then calculate the component time for each component, and then we total all the times, and then finally determine the lowest repeatable value. So this is a time observation sheet that enables you to look at, to see how a particular cycle, a particular task is done. And as you can see, on the 4th attempt, somebody didn't want to get sugar. So the times for the 4th attempt was down at 51 seconds. So therefore, we got an average task time of 72 seconds overall. So this is your lowest repeatable time. The next one is what we call a standard work layout. And what we want to do here is to indicate our takt time. Okay, so we need to understand the amount of customer demand. Remember, we talked about the takt time being the available working time divided by the customer demand. On the work layout, we also indicate the operator's cycle time based in the order of the operations, and it gives us a visual representation of the work versus the takt time. So here's a standard work layout, and what we've got is, again, to make a coffee, make a cup of coffee, and our objective at the end is to taste the coffee with a quality check. So we complete our header information first. We then draw the physical layout of the cell, which is number 2. We then number the operations in sequence and connect to show the process flow. We then indicate unavoidable work in process, if there is anything else there that we have to take account of. Indicate any quality checks and safety concerns, and then finally write down the takt time and the operation cycle time. So a standard work layout will let you see what you actually need to do in order to meet takt time. So on a standard work combination sheet, we use this to document the best combination of both manual work and machine work, because we get that quite often. We also use it to document the sequence of work assigned to a particular operator. We can use it to train operators in some cases, and we use it as a baseline for improvements. So this is a standard work combination table. So if you have a look here, you have walking 7 seconds, and then picking up a coffee mug, pour the coffee into the mug, put the creamer in the cup, get sugar 1, put in, get sugar 2, put it in, get a stir stick and stir it, pick up cup, go sit down. So this gives you the manual, automatic, waiting, or walking symbols in the top right-hand corner, and you can then add those on to your actual standard work combination table, and it will give you a very good pictorial view of the different elements within your standard work. So we complete the header, we enter the data from the observation sheet, we show the manual, machine, and walking times with the symbols, we indicate the takt time, and then we can obviously see the result. We also have what's called a process capacity table. And we use this to determine the machine and line capacity, also to identify the maximum output for a process, and also to document the breakdown of the total operator cycle time. So in this process capacity table, we're picking up some stock. So again, we complete the header, we determine the component tasks and the times, we determine the non-cyclic times. Okay, non-cyclic means that it's not dependent upon the cycle, and then we calculate the capacity for each particular task. And then finally, the minimum capacity is the maximum output that we get. Okay? So this one really helps you understand whether a process within your value stream is capable of meeting TACT. And if it's not, then what's your solution? You obviously have to increase that capacity by either adding more resource or doing some Kaizen to improve the output. We have a line balance chart as well that helps us, as the previous one did, to understand whether our line can meet TACT or not. And this is extremely useful when you start looking at a flow sequence within a particular line, and this gives you a very, very good visual as to whether or not you have to do something to either increase resource or do some continuous improvement, because you get a visual representation. So this is a line balance chart or a process balance chart. And as you can see here, we've got a sequence of operations. Operation 1, 2, 3, 4, and 5. We have a takt time of 60 seconds. And immediately here, you can see that operation 4 is 7 seconds above takt. And what does this tell you? It tells you that either you've got to take some of the work in operation 4 and possibly do it at operation 3 or 5, or if you can't do that because it's a specific process, then you will have to add more resource to operation 4, either another machine or additional people, in order to reduce that cycle time below takt. So this is a really good visual representation that helps you control your flow through your plant. So I've got 3 poll questions. Okay. Dave, what I'm going to do is I'm going to ask poll question 1. Then I'd like you to bring poll question 1 up for the audience. Then I'm just going to show poll question 2. So I'm not going to give you the answer yet. And Dave, you bring then poll question 2 up. And then I'm going to give you poll question 3. And then we're going to bring poll question 3 up. And then I'll give you the answers after those 3. So the first poll question is, standard work is 1, a set of steps to ensure we are meeting engineering standards. 2, a defined method to perform a task. 3, a process to ensure operators meet production needs. And 4, a set of instructions that will reduce costs. Dave, can you bring up poll question 1 for the audience, please?
Richard, would you like the audience to answer those questions when we bring it up?
Yes, please.
Okay.
Okay, so we've got the poll question up. Standard work, is it A, B, C, or D? I actually had 1, 2, 3, or 4 on mine, but that's fine. Is it A, B, C, or D? Okay, Dave, let's take that down. Okay. All right, so I'm now going to go to poll question number 2. A time observation sheet is used to what? Observe and identify all the elements in the process. Measure the operator against engineering standards. Assist supervisors in measuring operators. Or calculate hours earned. Dave, let's bring up poll question 2, please. So a time observation sheet, is it A, B, C, or D? I'll give you just a few more seconds in order to answer that one. Okay, Dave, let's close that one down. Let's go to poll question 3. A process capacity table is used to determine when maintenance of the equipment can be done, calculate standard costs, schedule production through the operation, or determine the machine and production line capacity. Dave, can you bring poll question 3 up, please? So a process capacity table is used to A, determine when maintenance of the equipment can be done, B, calculate standard costs, C, schedule production through the operation, or D, determine the machine and production line capacity. Okay, let's close that one down, Dave. All right, so let's have a look at the answer for poll question 1. So poll question 1, standard work, is a defined method to perform a task. Can we bring the results up for poll question 1, please, Dave? Excellent, 100%. Oh, everybody's right on target. Okay, let's look at poll question 2. A time observation sheet is used to observe and identify all the elements in the process. Dave, can we bring up the results of poll question 2, please? Okay, we got 85% for A, which was great. And then 14% to measure the operator against engineering standards. So remember, a time observation sheet is used to observe and identify all the elements in the process. Okay, Dave, let's close that one. Okay, let's go to poll question 3. A process capacity table is used to determine the machine and production line capacity. Dave, let's have a look at poll question 3. Answer. Excellent, 100%. Awesome. Okay, we can close that one off, Dave. Thank you. Excellent, everyone. All right, let's move on a little bit then. We've got about 20 minutes left, and then we've got time for questions. So, a standard work audit sheet is used to audit the new process, check and act under PDCA, formalize the new process, and act as a communication tool. So here's a standard work audit sheet. So we complete the header, complete the new element descriptions and times, draw the new layout, and then indicate the quality, safety, and any work in process. So now this is when you change a particular piece of standard work, you can now use this audit sheet to capture the changes. And in this particular case, we've got the coffee maker, and we had 41 seconds was the manual time, 7 seconds was the walking time, and 48 seconds was the total cycle time. So we also want to look at how we measure and improve. So this is a pretty good chart when it comes to standard work. This is called a day by the hour chart. And a day by the hour chart, it actually could be an hour by the minute chart if you wanted. So one of the things that we encourage organizations to do is to measure expected versus actual. And by measuring expected versus actual, you get a good idea of whether or not your production line is flowing correctly. If you report a day's worth of work once a day at the end of the day, and you are short of your target, then you've lost a day. If you report once an hour and you're short of your target, you've only lost an hour. If you report once a minute against your target, then you've only lost a minute. So imagine if you go for a physical checkup every 10 years and they find out there's something wrong. You've lost 10 years in order to be able to correct it. If you have a checkup every 5 years, then you've only lost 5 years. If you have a checkup every year, you've only lost a year. If you check up every month, you've only lost a month. So this is like taking the pulse of your organization. Use the day by the hour chart to measure and improve your performance. This is one of the hardest things to do, to get value adders to fill these in, for the simple reason that the leadership don't react correctly when they do fill them in right. The leadership should be there to support the people, to say, what do you need me to do to help you get back on target, or why was this particular issue there? Okay, we're going to do some problem solving. So it's really important that if you have expected versus actual charts, get the value adders to fill them in correctly, but then your response should be the right response to send the right message. This is the PDCA approach to what we call creating standard work. So under plan, obtain the standard operation for the process. In other words, agree which is the right way to do it. Then under the do, capture the current situation on video. Once you've got the video, under check, analyze the video and document it on the standard work chart or the standard work combination table, and then compare it with an existing standard operation. Under the act, we want you to analyze what you've just done and eliminate variation from the process using 5S, 7 wastes, and visual management. So it is a complete loop, and you start all over again trying to eliminate this variation that exists within your processes. So how do we implement standard work in production flow? So here's the steps. Gather the data for the value stream and the process step. Create your standard work for the process step and then implement the standard work as current. Verify results through measurement, your day by the hour chart or your time observation sheet. And then under ACT, measurement and standard work, audit for process improvement. So that's the sequence that you need to go. For information flow, create a current state value stream map, create a future state value stream map, create a standard work checklist for each process step. Implement a standard work plan, and again verify results through measurement, and then go through continuous improvement under the ACT on PDCA. So now we've got 3 more poll questions that we'd like to give you. Poll question 4. We audit standard work for either discipline employees that are not following the procedure, to ensure we meet our customers' requirements, to measure and adjust the procedure, to ensure our actions are delivering what is expected. So Dave, can you bring up poll question 4, please? Okay, so just a few seconds to answer this. Why do we audit standard work? Is it A, B, C, or D? A, B, C, or D? Okay, let's close that one off, Dave. Right, let's go to poll question 5. Which of the following best describes the foundation of a good lean system? Is it policy deployment and A3 thinking? Is it standardized work and preventative maintenance? Is it visual systems and Kaizen circles? Or is it stability and standardization? Let's bring up poll question 5, Dave. Which of the following best describes the foundation of a good lean system? The foundation of a good lean system. A, B, C, or D? Okay, Dave, let's close that one off. And we'll go to the final poll question of the day. Which of the following is the best definition of perfection? Identify waste, eliminate waste, focus on creating value, engaging teams of people in regular problem solving across the value stream, being innovative in both product and service capabilities, specify customer value, and grow market share. Let's bring up poll question 6. Dave, which of the following is the best definition of perfection? Is it A? Is it B? Is it C? Or is it D? All right, Dave, let's close that one off and we will look at some answers. So, poll question 4. We audit standard work to ensure our actions are delivering what is expected. Let's bring the results up for poll question 4. Okay, So to measure and adjust the procedure, interesting. 80% said it's to measure and adjust the procedure. It's actually to ensure that our actions are delivering what is expected. So remember that we talked a little bit about creating standardized work and what's the purpose of creating standardized work. And the first is so that you know what to do in order to do the job right. If your whole team leave you and you still have to get production out, you use standard work in order to be able to do the job. And why do we audit standard work? To ensure that our actions are delivering what is expected. So we need to audit the work to make sure it's being done to standard. Okay, so everybody should be okay with that one. All right, Dave, let's close that one off. Let's bring up poll question 5, which is the best describes the foundation of a good lean system. So bring up the answers to question 5, Dave. Excellent, 100%. Well done, team. Love it. Okay, close that one off, Dave. And we'll go to question 6, which is the following is the best definition is the first one. Dave, let's bring up the results of question 6. %. Got it. Okay, so very, very good. 92%. So which of the following is the best definition of perfection? And you need to identify the waste, eliminate the waste, and focus on creating value. Awesome, Dave. Let's close that one down. All right, we're getting close to the end. So let's just have a quick look at a few more things. This is the PDA approach to managing standard work. So authorize and issue the standard operation for the process, train the operators and use the standard op, audit the process and operator using the standard audit sheet, and then improve the standard op through structured continuous improvement. So how do we do job instruction? So this is what we're going to use here for operator training. We create what we call a job instruction breakdown sheet. This is what we actually use in the do. Train the operators and use the standard operation. Do we use this? The simple answer is no, we don't use this. We actually use what we call a job instruction breakdown sheet. So now this is an instruction from the trainer to the trainer, so that when the trainer actually visually shows the person how to do the job, this is what he would say. I've got 4 important steps. The first step is to position fold. The second step is first fold. The third step is hang shirt. The fourth step is fold flat. Now I'm going to show you again. This time I'm going to give you some key points. The first step is to position fold, and I've got 2 key points. Middle, quarter, pinch 2. Level, pinch top. The second step is first fold, and I've got 3 key points. Right over left, level, pinch bottom. The third step is hang shirt, and I've got 2 key points. Left hand out, level. The fourth step is fold flat, and I've got 2 key points. Arm under and equal. And you can see I've got reasons there as well. So the trainer will actually be telling the person as he's doing the job. So the person will learn it using what we call a 4-step method. This is training within industry job instruction. So why are we using JI? So the job breakdown sheet tells us the tools needed for the job, whether we require 5S prior to training, the safety key points, the quality key points, the tricks or efficiency key points, and they provide question points for daily continuous improvement leaders. So how to prepare materials, how to mix ingredients, how to maintain area standards, how to weigh materials, how to fill out production and quality records, etc. We can then go and see whether the work is being done correctly in the work sequence by using a standard work combination table. And then for each of the particular machines, we've got the standardized work in place. But we would use a 4-step method to train. So this is the 4-step method that has been tried and proven since 1940s. And step 1 is prepare the worker. So put the person at ease, state the job, find out what the person already knows, get the person interested in learning it, and then put them in the right position so they can see what you see. And then present the operation and use your job instruction breakdown sheet, which was this one. Okay, and as a trainer, you will say these steps in the right sequence. Tell, show, and illustrate one important step at a time. Do it again, stressing key points. Do it again, stating the reasons. But don't give them any more information than they can master at any one time. Then you get the person to do the job. So get the person just to do the job without saying anything. And then have them explain each step to you as they do the job again. Then explain each key point as they do the job again. And then have them explain the reasons. And then make sure the person understands, and you can keep going until you know that they know how to do the job. Step 4 is follow-up. So you put the person on their own now and tell them who to go to for help if they need it. Come and check on them very frequently and encourage lots of questions. And if you follow this method, you can never ever say to somebody that person is untrainable. Because if the worker hasn't learned, the instructor hasn't taught. So, keys to implementing standard work. The processes must be developed and implemented by the people that do the work. Standards must be simple and practical enough to be used every day by the people doing the work. Training on standards is critical. Employees should not have to refer to the standard in doing the task, but rather have them memorized. Standards should be designed with internal, external customer value in mind. And standards are to identify issues and not to assign blame. If something goes wrong with a process, we use the standards to find out why and to implement the right corrective action to the process. We never blame the person doing the job. Never. So here's a SIPOC model. So again, our inputs here, man, machine, material. The method controls the process. So we've got standard operations, PDCA, and our outputs are quality, cost, and delivery. And this is what the customer sees: quality, price, and delivery. So customer satisfaction is paramount. So finally, why do we need standard work? To maintain a safe working method is the first one. To ensure it's possible to produce a product to the required quality in the same time every time. To capture the knowledge. To involve everyone in defining the process. To define the working sequence. Where there is no standard, one, it is difficult to identify opportunities for improvement as you don't get a stable environment. And two, there's no way of knowing whether improvements have been made. Priority of improvement, obviously safety first, quality second, ease third, and they're highlighted through key points on our job detail sheet. Safety points should be contained with a time duration for root cause elimination or review. Quality points should be problem solved to eliminate root cause or error proof. And then ease points should be tackled to make things easier for the people doing the job. Standard work, who should do what? Well, have a think about your particular company. Who use and develop standard operations? Who highlights abnormal conditions? Who aids in improvement? Who defines standardized work, trains, etc., etc., etc. So best practice, okay, the worker does the first one, supervisor does the second one, manager does the third one, and a senior manager looks after the last one. And really they should be the ones that actually use and develop standard operations, the people who do the job. So what are our benefits? We maintain a safe working method, define our working sequence, we establish cycle time, increase ownership, and it can be used to check if quality cost delivery targets are not achieved, and we capture the knowledge. Philosophy, standard work ensures that a task can be performed in the same time every time, achieving the same quality levels in a safe manner, irrespective of the differences between people. When we can get the quality cost delivery results every time, then we release time to do real improvement. Okay, I think I've got probably 1.5 minutes left before the end of the webinar, and I'm just wondering if we might have any questions.
Okay, thank you, Richard, and we'll now review the questions that we have. If you have any questions, please submit them on the right side of your screen. Here's one. Can you still train someone without having standard work in place?
That's a good question, Dave. The simple answer is yes. You can train somebody without having standard work in place. What you have to do, however, is have an agreement with the group doing the job that the method you're going to train is in fact the right optimal method. And then you would create a job instruction breakdown sheet which is using the 4-step method, and then you could train a person to do that particular task without actually having your standardized work in place, your documents and stuff. So the answer is yes, Dave, you can still do it.
Great, thank you. One other question here. In the past, standard work has been created by engineers, either quality or process. Why is it important to get the operators involved?
Oh, that's a good one. I think I've mentioned previously the most experienced people doing the job are the people who do it all the while. And getting them involved to do the standard work is paramount. The process engineers understand the process, yes, but the people doing the job are the best people to create the standard work. So in some cases where you need technical support, I would suggest a combination of a process or a quality engineer liaising and doing a buddy system with the person who's done the job every single day to create the standard work.
Great. Thank you for all your questions. And thank you, Richard, for sharing your knowledge and experience with us over this series. This brings our webinar and series to a close. Please don't forget to fill out the short survey that'll be in your inbox. And thank you, everyone, for attending, and have a productive day.
Thank you all.